Hi, my name is Mike Wilson. I'm a senior relay application engineer at Mega Group. Today we're going to cover testing a 50P1P element in an SEL-710 Motor Protection Relay. Now we've covered the instantaneous, the phase instantaneous element in a previous video, but this one's going to be a little bit different because we're going to be using different units for the setting. And I feel like this is important enough to make a separate video for. So with that in mind, let's go ahead and get started. First of all, we're going to be using an SMRT 46 Delta, just Smart 46, with RTMS testing software. That's a relay test management software available through PowerDB on the megger.com website. Again, this is freeware. So download, use at will. So with all of that being said, we're going to go ahead and get into the video here. Okay, the first thing that we're going to do is open up Accelerator Quickset, and I've already read in the settings from the SEL-710 that I have here. So the first thing I'm going to ask myself from testing the 50P1P element, of course, is what is the 50P1P setting? I'll find that under Group 1, Set 1. Come over here to Overcurrent Elements, and we see Phase Overcurrent here. So when we click on that, we see that 50P1P Phase Overcurrent Trip Pickup is 7.38. Now, normally in most of the SEL relays, this 50P1P pickup, it's given in secondary amps. So this would lead one to believe that 7.38 is the expected value if you were doing a pulse ramp to find the pickup. However, this isn't the case with this relay. So we see here the 50P1P value of 7.38 is actually a multiple of full load amps. It's the full load motor amps here, and which is naturally going to lead you to the next question: what are my full load amps? So we'll find that by going here, staying under the Set 1 tab, but we're going to go to the main, and we see here that we have FLA1 motor full load amps at 400. And of course that is a primary value. So we jot that down, 400. And if we multiply that by the 7.38, we should come up with just a hair over 2,900. That comes up to 2,952 amps. Again, 400 amps for the full load amps. That's prime as a primary value, and so is this 2,952 amps. Now, what does that mean for us? That means that in order to get the secondary, in order to get the value, the expected secondary value, we need to divide that 2,952 by 120, which should give us a little shy of 25 amps. It looks like 24.6 amps. So 24.6 amps is the expected value that will get that 50P1P element to assert on. We're going to go ahead and we're going to come up here to Communications tab, and I'm using a SEL-662 C662 serial cable and connecting to the front port of the relay. I'll pull up my parameters here, communication parameters, and just double check, make sure that looks right. Okay, and baud rate 19.2 for this one, and apply. And I'm just going to look over here into the left-hand side and see. Once I see that red and green, of course I'm going to see the transmit no matter what, but the receive means that I have the correct parameters, so I can go ahead and hit OK. As opposed if I didn't see that green receive, I could go ahead and cancel instead of letting it go through. It'll attempt to communicate with the relay for roughly 45 seconds unless you've made a change to your terminal options under tools here. Anyways, so now that we've made our connection, I'm going to pull up the screen here and log in. That's a default password. So you see, we can go to level 2. And I'm going to go ahead and I'm going to use my set space L space out 101 first command. And I see that right now I have it set at, this is a negative sequence time overcurrent element. So I'm looking for a 50 P1. And we try that again, 50 P1. And I want to point out here now we're setting the output out 101 for the SEL-710, and whenever we put in that command that set space L space out 101, it immediately takes us to the logic definition for that output, and we can see that as soon as we've entered that, we go into out 102. So this out 102, you see it's an out 102 fail-safe, yes or no. And of course, this is set for no. But a lot of times what happens is that maybe this out 101 or whatever spare output that you're using, it has been set for fail-safe. Maybe it was being used as a software hardware alarm or something else. But a lot of times it's already been set, and it's been set for fail-safe. So whenever you go in and you define your output and you run your test, and you a lot of times you won't get the result that you're expecting. You're going to fail a failure or an error about the contact not being in the right position. So just double check that. And in order to do that, I can come up here and I can do a Shift-6, and that's just my caret sign, and that backs us up in the terminal. It's a little shortcut. So I see that I've entered that twice, and I'm back to the out 101 fail-safe, yes or no, and I see the out 101 fail-safe is set to no, which I knew that before. I've been testing on this relay for quite a while, but it's worth bringing to your attention. And we see the out 101 is set for 50P1P, and I'm just going to go ahead and click end, save changes, yes, and go ahead and clear the SER. All right. Now with that, I'm going to come over here to PowerDB, and we're going to start with a new file. And we're going to open up a brand new file, and of course we have routines, we have templates for these relays and everything. But I think it's really important to understand how to put together one of these tests, how to be able to build a template on your own. It gives you a more thorough understanding of what's going on behind the scenes with the relay. I've always suggested that these templates, if you're an experienced relay technician, use the templates, because it saves you time. No need to reinvent the wheel. But if you're up and coming, you're learning, take the time to learn how to build these, because it makes troubleshooting them so much easier. Now we pulled up a new file, and we're at the home screen here, and I'm just going to make a couple of adjustments. I had this on symmetrical component mode, but we're going to start off with the at the home screen, and we'll come over here to select new test, and then we'll pick standard ramping. Okay, so now starting back here at our standard ramping screen, I can see that I have all 3 channels enabled, and I have a current pre-fault set at 1 amp. Now I don't with instantaneous elements, I don't normally run a pre-fault, so we're going to say 0, and we use the balance wheel to adjust all of those amplitudes, and we can see here that that right now we have this set up for performing a stair ramp. What we want to do for an instantaneous value is we want to use a pulse ramp. And we're going to go ahead and we see here that we have a 1 second pre-fault time. I like to extend that pre-fault time for about 3 seconds because we're going to run 3 or 4 different tests here, 3 or 4 different ramps, one for each phase, and then all 3 together. And so I want to leave a few seconds of pre-fault of 0 amps pre-fault time to each test. I'm also, because I usually use a plus minus 5% error, and you can look into the specifications for the relay in the instruction manual, and actually define what the manufacturer's tolerances are for this value. But just rule of thumb, I usually do plus minus 3 to 5%. So my starting value, I'm going to let my starting value. I'm going to start off at 90%, and then not to exceed 110%. Our expected value is, again, that's the 24.6, which we got from dividing the 2,952 amps by the CTR ratio of 120. And we have this. So if we're looking at this, we have 3 seconds of pre-fault at 0 amps. Then we jump up to 90% of the expected, 90% of the 24.6 amps. We have a dwell time of 12 cycles. We pulse for 12 cycles, then we have a dwell time for 12 cycles. Now our resolution is a little fine right there. That's 10 milliamps. So I'm going to change this to 1/10 of an amp just for time's sake. Also, as I'm looking at this, what I see here is that I'm going to perform a pulse ramp, and this is just one single ramp, and all 3 channels are going to be used. I don't want to do that. What I want to do is I want to set this up for 4 ramps. So I'm going to click set number of ramps, select 4. Now I'm showing the parameters for the first ramp. I want to disable channel 2 and 3. I just want to ramp channel 1, and these are the parameters. So then to do channel 2, to do B phase, I'm going to click on this. I'm going to go to ramp number 2, and I'm going to change all the parameters for this as well. First, I'm going to check this as ramping channel 2. It's going to be a pulse ramp. I'll have 3 seconds of pre-fault time at 0 amps. We're going to start at 90% of the expected. We'll pulse for 12 cycles and then dwell for 12 cycles. Our expected value here needs to be 24.6. And our resolution will be 100 milliamps, or 1/10 of an amp. And our do not exceed will be 110%. And that do not exceed value is there just to give the test a place to stop. If you didn't have your output wired correctly, the binary input wasn't registering the state of the contact, then you want somewhere to stop that test to say, hey, something is far enough out that we need to stop and take a look at the test parameters or the connections. So we'll go ahead and accept that. Now now we've done one for channel 1 and channel 2, ramp 1 and ramp 2. Let's go to ramp 3, and ramp 3, of course, is going to be our C phase. It also will be a pulse ramp with 3 second pre-fault. We're going to have an expected value of 24.6. Our start value is going to be 90% of the expected of the 24.6 amps, not to exceed 110%, and 100 milliamps, or 100 milliamps for our resolution. And that leaves us with our final one, which is ramp 4, and that would be channel 1, channel 2, and channel 3 pulse ramp. Again, 3 seconds pre-fault time at 0 amps, and 90%, starting at 90%, not to exceed 110%. And that expected value is 24.6. It doesn't matter what order you put these in. It's just as long as you enter all the parameters. And 100 milliamps as our resolution. Okay, now with all the parameters set in here, now we've set the output of the relay. We've made all the connections. You can't see that here, but we've made all of our connections from the relay to the test set, and we've set up all the parameters for each one of our ramps. We can do a double check here. We can look at ramp number 1, and we see channel 1. Everything looks good there. Ramp number 2, and we see it. We're ramping channel 2, and all of our parameters are the same as the previous one. 3, channel 3, everything looks the same, and channel 4, all 3 phases with the same parameters. It's important to go back and take a look at these, because it's very easy to make a change, anticipating the next ramp before you actually come in here and select the next ramp. And once you've done that, you basically overwrite that overwrite the parameters that you intended to set for that previous ramp. So now with everything here, we don't have to go back to ramp 1, but I will just for clarity, and we're ready to run the test. We're going to use the play button here, and let's see how this turns out. Now, as you can see, the timer is counting down, and we immediately hit it with about it was 22.4, 22.6 amps. And we're looking for that 50p1p element to pick up, and it looks like we did pick up at 24.6 amps. So now we move into our second ramp, and we've already went through our 3-second pre-fault time, and we're ramping up to our 24.6 expected, which again we asserted the 50p1p at 24.6 amps. Now for the last one, the same as the first two. We see it coming in at 24.6. Actually, this one is the last one, the ABC fault. And there we go. Now that we've ran that test, it's going to ask us if we want to. It's going to give us a value here, even if this was a failing value. I would go ahead and say add to the report, because until you've run the test, you can't save the test until it's been ran, and that's either by running it real time or running a simulation. So I'm gonna go ahead and hit add to report, and this pulls up my test results. Now, with this test result, I can come up here, and anything that's in blue or dark blue, I'm not sure exactly what color that is, but I can modify this. So if I want to say that this is my 50p 1p test, and I can come over here to allowed percent error. I can do plus minus 5%, and you can see that adjusts whenever we change that tolerance value. It will adjust the minimum and maximum values, and we have our expected value. This is our actual pickup. We see down here we still have the 10%, so it has a minimum of 22.14. But once we change this to 5%, it's going to change to 23.37. So 5, 5, and 5. What's our results? We have 0% error. It came in exactly as expected. So now that everything here looks good, I'm going to go ahead and hit the check mark to go to the previous screen. Should take us back to our test screen. And I can't overemphasize save early, save often. Now that we have this test result, we have a test result. We want to come up here to our save. And I'm just going to put in here SEL-710 50p 1p test. And I'll go ahead and save that. It'll take just a moment here. And once that test is saved, even though we're still in the test screen, I can come over here and I can click on home and go to predefined tests. Now, before, when you first opened up a new file, that predefined test, there were no tests under there. It gave a text version of selecting a new test. Now we can click on this, and we see that we have a test group. By default, it's going to, if you haven't set this up prior, it's going to give you a default name of tests as your test group. But you can see that 50p1p ramp test. This was what we actually entered into the test results when we modified the title of that test. If we want to give this test group a different name, we can, with this test selected, we can come down here to the third button from the bottom, and it's Edit Test Attributes script. I can click in here, and I can call this my instantaneous. And hit accept. Now, when I come back here to run predefined tests, I can see that test group 50p instantaneous test and 50p1p ramp test. So hopefully that will give you a little bit of insight on how to test this instantaneous element. I know that the first couple of times that I ran the test, I made the mistake of not looking at what units that was given in, and so when I ran the test, I assumed that it was going to pick up at 7.38. Of course, it didn't, and it got me looking at it a little bit closer and realized that there's a little bit of math that has to go behind that to get that test to pick up, to actually test the element that you're really intending to test. So If you have any suggestions, if you've been watching this video and you have any suggestions or tips, please post them below. And otherwise, I will see you next time. Thank you.